Hi, Year 7. Today we're looking at exothermic and endothermic reactions. This is our title. Learning outcomes are: I can describe the characteristics of exothermic and endothermic changes, and I can classify changes as exothermic and endothermic. This is an activity I would like you to do. Please pause the video and write out these sentences. Ice turns to liquid water when and you need to choose from these answers here: evaporates, condenses, or melts. You need to choose from from these answers, and each of the places where there are gaps, you need to choose from the answers as well. Energy is transferred from is that going to be water or surroundings, to the surroundings or water. Just choose one answer. Therefore, the water particles can move around, one or two, freely. If enough energy is transferred, the water particles can, and then choose between these three answers, and form and that's either going to be a gas or a solid. When you have completed this task, then carry on with the video to mark your work. Well done if you got the answers right. Ice turns to liquid water when it melts. Energy is transferred from the surroundings to the water. Therefore, the water particles can move around more freely. If enough energy is transferred, the water particles can evaporate and form a gas. Give yourself a mark out of 6. The next thing that you're going to do is to decide if some simple reactions undergo exothermic or endothermic changes. This is the equipment that would be used and the safety precautions that one would normally pay attention to. Before that though, let's look at some definitions. Exothermic reactions. Well, what does the word exothermic mean? This is when a chemical reaction this is a chemical reaction, that transfers energy to the surroundings. Endothermic reaction, on the other hand, is a chemical reaction that transfers energy from the surroundings. Here is a diagram that compares exothermic and endothermic reactions. Energy is normally conserved in chemical reactions. The total energy of the system is the same before and after a reaction. Let's look at endothermic reactions here. If you look at this ice cube, it is melting. And the reason it's melting is because it is taking in heat from its surroundings. When I say surroundings, can you see where the arrows are? So anything outside the ice cube is its surroundings. The endothermic reaction is cooler than the surroundings, and therefore, normally with endothermic reactions, it's going to feel cool. So if you are mixing a chemical in a test tube, for example, chemicals in a test tube, and if it's an endothermic reaction, the test tube is going to feel cold because it's taking in energy. Exothermic, on the other hand, the reaction is hotter, and this is because it's giving out energy to its surroundings. Therefore, if you've got a test tube again, you're mixing chemicals in a test tube, the test tube is going to feel warm, it's going to feel hot. Sometimes people get these two terms confused. If you learn the definitions, it will be easy. But I have found a way to help me remember the differences between the two. Endo sounds like indoor. So it's something that is going in. You're putting energy into the system from the surroundings. With exo, that reminds me of the word exit, and I've highlighted different letters just for you to, well, just to help you. Use it if it helps you, or come up with what you would use, what can help you remember the differences between endothermic and exothermic reactions. You are going to be watching or seeing some experiments that have been done in school on exothermic and endothermic reactions. I would like you to pause the video and write down your prediction. If one of the reactions you're going to observe undergoes exothermic change, predict what you expect to happen to the temperature. Another thing that you can do is there's a table that is coming up on the next slide, which I would like you to draw. Again, you will need to pause the video for that. And then you can try and guess to see whether you know whether an exothermic or endothermic change will happen. It doesn't matter if you're wrong, just have a go. Also on this screen is just showing you the methods for the different reactions. Okay, as I said, pause the video now and draw the table, and then you can write down your observations as I speak on the video about the chemical reactions or the experiments that I have done. The topic of exothermic and endothermic reactions involves a series of experiments. The first one that I'm going to do is ammonium nitrate and just adding it to some water and seeing what happens. Normally you'll be asked to do predictions of whether this is going to be an exothermic or endothermic reaction. So for ammonium nitrate in water, hydrochloric acid and sodium hydroxide, ammonium chloride in water, and hydrochloric acid with magnesium ribbon. You can do your predictions and just, even if you don't know, at least have a guess as to whether it's going to be an exothermic or endothermic reaction. And then once I've done the experiment, you can come back and see whether your predictions were correct. This is what ammonium nitrate looks like. I'm going to put a spatula, let me try the other end, a spatula full into the test tube and then measure the temperature. Okay, let's have a look at the temperature. Now remember we started at 24 degrees. As you can see, it has gone down a bit. And if I fill the test tube, it feels quite cold. Now the reason I am using the thermometer is because you are unable to feel to fill the test tube. So let's see. So it's gone down to 16 degrees. This next experiment involves adding 10 ml of hydrochloric acid over there and 10 ml of sodium hydroxide together. I have to record the temperature of the hydrochloric acid, so let's see what it is. The starting temperature is 23 degrees C. It's gone up to 25 degrees C. Okay, let's see if you can see that. If I hold it straight, now it's gone up to 26 degrees C, sorry. Okay, so we record that as well. For this experiment, I'm going to dissolve ammonium chloride in some water. So I have already added 2 ml from this bottle into the test tube. The temperature is 24 degrees C. Okay, now if you look, let me try and focus here. You can see that the temperature has gone down and it's still going down. I'm trying to keep the camera steady. It's still going down from 24 degrees is where we started. It went down to 19 degrees C. The test tube also, the test tube feels cold to touch. Okay, again I've recorded the temperature. Now the observations that I have been mentioning, you can be writing these down as I have been talking. Okay. This one we've done before, but now we're looking at it in terms of exothermic and endothermic reactions. So I have put 2 ml of hydrochloric acid into the test tube. The temperature, let's see what that says. The temperature is at 24 degrees, and then I'm going to add the magnesium strips. Write down your observations. Okay, and then let's feel it. The test tube feels hot. Okay, let me try and focus. Okay, you can see it's over 40 degrees. It's going close to 45 degrees. So the temperature, let me just pause the video. The temperature went up to 43 degrees C. Write down your observations. If you're not sure, then just rewind the video and listen to the observations that I mentioned. For the magnesium ribbon, it feels hot, and you can see some fizzing. And this also links into signs of a chemical reaction. If this is left long enough, it will completely dissolve. Now, once you've finished filling in your table, the middle column, I want you to go through each one and decide whether it's an exothermic or endothermic reaction for each one of them. And then there will be some questions for you guys to answer.